Excess limiting reactant problems, page 5. I'm going to do problem number 2 and walk through this in something besides just hydrogen and oxygen. We can do these really for any equation. So it looks like we have 132 grams of propane, which is C3H8. And this is something I think on a gas grill would be a good example of a use of propane. And we combine it with oxygen. Looks like 384 grams here, and we get CO2 and H2O. So remember, a combustion reaction of a hydrocarbon with oxygen gives CO2 and H2O. To balance these, I would usually put a 1 here. I'm going to do this pretty quickly. If I put a 1 here, I have 3 carbons, so I'm going to put a 3 right here. So now I got 3 carbons, and I have 8 hydrogens, so 4 times 2 would be 8 hydrogens. And there's oxygens all over the place, so we got to kind of figure that out. If I look here, there's 3 times 2, there's 6 oxygens, plus 4 more oxygens, which would be 10, and put a 5 here because 5 times 2 would be 10 oxygens. So it looks like it's 1, 5, 3, 4 ratio. Well, not so easy to think about this with these ratios right here. Okay, so we balance the equation. What's the limiting reactant? The limiting reactant, we have to compare moles of these things here. So we know grams of propane and grams of oxygen. We got to convert that to moles. So that's what we're going to do. So I'm going to do this and take my molar mass of propane, which is 132, and I am going to say 132 over the molar mass of propane, which is 44. And that's going to equal 132 over 44. I think that ends up being 3. But I'm going to kind of keep my figures here and try to keep 3 figures. 132 divided by 44.0 equals, and I'm going to say 3.00 right here. Where did I get the 44 from? I did 3 times 12 for carbon, 8 times 1 for hydrogen. I got 44.0 grams per mole. So now I have 3.00 moles of C3H4. If I went to an ice box, which I will do, remember I for initial. So I'll put the I right here, the C for the change, and then the E for the end. Okay. So I said I have 3.00 moles. I might just type that in. Might be a little bit quicker here for C3H8. Okay, I'm going to figure out 384 grams of oxygen. How many moles of that for oxygen is that? So I'm going to start here and say 384 divided by the molar mass of O2 is 32.0, and that's going to leave me with 12.0 moles. All right, and I'm going to put 12.0 right here. Do we have any CO2? Not at the beginning, so this is going to be a 0. If I wanted to carry over to our H2O, I could say that's a 0 as well. All right, let's look at our questions. So we have 3 moles of C3H8, 5 moles of O2. What is our limiting reactant? Oh, well, I have a lot more O2 than C3H8, so that should be in excess. Be careful, 5 to 1 is a big ratio. This is one that's pretty hard to do in your head. What I'm going to do is take this number, divide it by its coefficient. So I'm going to take 3.00 over 1, which equals 3. I'm not even worried about sig figs here. And then I'm going to take this 12 and divide it by 5, or this 12.0 divide by 5, and I get, I think, a 2.4. I'm like, oh, 2.4 is less than 3. So the one that's a smaller number is going to be my limiting reactant. So even though I have a lot more moles of oxygen, it's not 5 times as many moles. So that becomes my limiting reactant right there. And then my C3H8, even though it's a smaller number of moles, is going to be the excess reactant right here. So that's supposed to be LR, limiting reactant, and there's our excess reactant right here. Okay, all of my limiting reactant gets used. So this is going to be a 12 or 12.0. And then what I have to do is take 12.0, I'll try to make that decimal there, times 1/5 to get this number here, which just so happens to be 12 divided by 5 or 2.4, but I'll keep the figures there, say 2.40. It's a decimal, so it's 2.40. Now notice these are minus signs here because they're reacting. And what am I left with? 0.60. Can I have less than a mole of something? Yes. A mole is 6 times 10 to the 23rd. You can certainly have a fraction of that. So that's 0.60. And my limiting reactant would be 0. Okay, I haven't completed this, but I've done quite a bit of this icebox. Let's look at our questions and answer them. We balance the equation, so check mark that. What's the limiting reactant? We said that was the O2. So I'm going to type that in and say O2. And what reactant is in excess? Well, it's got to be the other one. And how many moles are left over? The 0.60. So I'm going to say 0.60 moles of C3H8. That would be the excess reactant, and this is in terms of moles. It says, what mass of carbon dioxide is produced? So we can figure out this and this, but there's no questions about the water, so I might just let it go and not answer them. I'm going to focus mostly on the carbon dioxide. And when I look at this, my limiting reactant is 12. I can say 12 times 3 divided by 5, and I end up getting 12 times 3 over 5 gives me 7.20 right here. So I have to start with the limiting reactant and then multiply by 3/5. Now, could I say 2.40 times 3/1? Yes, that would also give you 7.20, but you wouldn't want to use this 3 or you wouldn't want to use this 0.60. So I usually start with the limiting reactant, go through my mole ratio, 12.0 times 3 divided by 5, which is like 0.6. 12 times 0.6 gives me 7.2. Okay, you don't have to do this one over here, okay? But if I did, I would be 12 times 4/5, and I think it ends up being like 9.60 for moles of water. Well, if I add those two up, 0 plus 7.20, it's going to be 7.20, because we typically, and certainly we will always assume there's no product at the beginning. So this, just a reminder, this number was what we use for the excess. And then this number is going to be, now be careful, this is going to go down here, but that's moles. So I have 7.2 moles of CO2, but I got to multiply that by the molar mass, which by coincidence just so happens to be 44 grams, just like the C3H8. That's a coincidence. Okay, I times that by 44.0, and I end up with moles times grams per mole, because I could say 44 times grams per MOL, and that's going to equal, and I believe I get 300 grams grams of CO2 right here. Okay, to review, I'm given grams. What do I do with my grams? I convert to moles. Moles of this, moles of this. I go to my ice box. Okay, we'll complete the box. Okay, it's a cool way to solve these problems, the ice box. Okay, so I take that moles and moles, and I got to figure out the limiting reactant. Just because this moles is bigger doesn't mean it is, because it's bigger in the equation. I take the 12 divided by 5, I get 2.4. I take the 3 divided by 1, I get 3. The smaller number is the limiting reactant. All my limiting reactant reacts, leaving me with 0. 12 times 1 over 5 gives me 2.4. Notice this number is less than this. If this number were greater than this, I have the wrong limiting reactant, and you got to flip them around. Okay, but this number is less than this. I can subtract to figure out moles of excess reactant, and that's the 0.6 moles of C3H8. I can also go through my limiting reactant to determine the amount of either product. In this case, we asked for CO2, so I go 12 times, and what is it? Times 3 over 5. 12 times the 3 over the 5, and that gives me 0.72. And that 0.72 moles, I take that, but I'm asked for mass, so I got to multiply by the molar mass of CO2, and that gives me the 317 grams. All right, hope that helps, and let me know if you have questions. Thank you.